Hey guys, good morning. So actually it's not the morning, but anyway. So just uh, now I'm not able to make a original video for you because I'm very busy right now. But I'm going to explain the thing that you don't understand based on the video that I have shown to you during the lesson. So there are some figures that have reflection symmetry and which they have a line of symmetry, at least one. But some figures have no this reflection symmetry, it means they have no line of symmetry, but they have rotational symmetry. But there are some figures, remember that, there are some figures they have both reflection symmetry and rotational symmetry. In the given example here, we have this figure has only rotational symmetry, no reflection symmetry because it doesn't have any symmetry line. For the rotational symmetry, two things is important. One of the thing is order of the rotational symmetry, and another thing is angle of the rotational symmetry. So order of the rotational symmetry means in a full rotation, I mean in if we turn the shape 360 degrees, so in a full rotation, how many times the given shape will be exactly the same in the same position during a full rotation. This number of times represent the order of the rotation. The angle of the rotation means what's the smallest number of degree, what's the smallest number of degree that if we turn the shape in that degree, the shape is going to be the same as itself. So it means that in which degree the shape will be the same first time during a clockwise direction with a full rotation 360 degrees. So now first let's just discuss the shape that has no symmetry line, has no reflection symmetry, but it has rotational symmetry. So we'll come to other shapes that they have both reflection symmetry and rotational symmetry. So let's go on. This figure has no reflection symmetry, but has rotational symmetry. And now just we are going to turn the shape based on the line, the center line. But note that for the rotation, the center of the rotation is important. So if we turn the shape based on the center of the shape, it will rotate like this. If we move the center of the rotation a bit upward, then the rotation position will change, as you see. So now let's just move that the center of the rotation to the top, one of the vertex of the triangle. Then the rotation will change completely. You see? So this is the quick review for the center of the rotation, and let's go back to our rotational symmetry. And now we are going to turn this shape based on its center. So this is my center of the rotation, and I am going to turn the shape 360 degrees, and this is my counter. What for does it stand? It stands for the counting then how many times this shape is going to be the same as itself. How many times? Okay, and this number will represent our order of the rotation. Okay, order of the rotation. Okay, let's see. Let's start turning in a clockwise direction for rotation. Okay, 0 degrees. Uh-huh. 90 degrees. Let's check in the 90 degrees. It's not the same as given. So my counter is still 0. Let's go on. So that's it. In 180 degrees, the shape looks like the same as given, so my counter needs to be 1 now. Okay, then let's go on because we need to go till 360 degrees. After 90 degrees, it's now 270 degrees, and the shape is not the same as given, so my counter is still 1. Let's go on. And now, 360 degrees, it's also the same as given, so my counter needs to be 2 now. Okay, I have completed my mission for this rotation. I needed to rotate it 360 degrees, and I did it. So, I have counted the number of times that the shape looks like the same, exactly the same as given. So, that number is 2. So, my order is 2. Okay? My order is 2. This number represents the order. Order is 2. Okay? And then, the degree of the rotational symmetry is what is the smallest number of the degree, that if you turn the shape in a clockwise or counterclockwise direction, the shape needs to be exactly the same as given. So that degree is, let's go a bit back. Okay, we have started turning 0, 90 degrees. It's not the same, so let's go on. 90 degrees is not the degree of the rotation. Uh, Now, 180 degrees. In 180 degrees, it's the first time in 180 degrees the shape looks like the same as given. So the degree is 180 degrees. Okay, that's it. Let's continue with the other examples. Okay, okay, here we have four shapes: oval, square, equilateral, triangle, and circle. Now we need to find the order and the degree. But here it's calculated only the order, but I will show you the degrees. So my counter is going to count the order of the rotation. Actually, how many times the given shapes will be the same, exactly the same in a full rotation. How many times? Let's go on. Okay. So 1 in 180 degrees. So first time it appears the same in 180 degrees. So the order of the rotation will be 2, and the degree of the rotation will be 180 degrees. Okay, so let's go for the second shape, square. Okay, 90 degrees, 180 degrees, 270 degrees, and a full rotation, of course, it's the same as the given. So 4 times. Now order is 4 for this shape, and the degree is 90 degrees because in a 90 degree the square will be the same as given first time. Okay, let's go on the triangle. 120 degrees, 240 degrees, and 360 degrees. So order is 3, and the degree of the rotation is, let's see it again, 120 degrees. So 120 degrees is a degree of the rotation, rotational symmetry. So, and order is 3, of course. And now let's see what will happen for the circle. Okay, so in a full rotation, then the circle is always the same as given. So if we are if we are rotating the circle based on its center, so it's always the same. So it means that so many rotational or so many orders for this, and so the degree for this circle is any degree, any number, any amount of degree. Any degree just different from 0. It can be 1.2 degrees, 2 degrees, 5 degrees, in any degrees. It will be the same as given. So just for the triangle, we have an order of 3. Rotational symmetry has an order of 3 and 120 degrees, 90 degrees, 180 degrees, and that's it, guys. So, but note that this is regular polygon, right? Because all sides and all angles are the same. All angles are 90 degrees and all sides are the same, as you see. And this is also regular polygon. This is equilateral triangle. All sides are the same and all angles are the same, 60 degrees, right? And so let's try to find out the connection between their sides, number of sides for rotation, and the degree of the rotation, and the order of the rotation. The square has um, 4 sides, and the order of the rotation is 4. The regular triangle has 3 sides, and the order of the rotation is 3. And so square has 4 sides, right? And 360 degrees divided by 4 gives us 90 degrees. It's the same as the degree of the rotation. This is the first time the square is going to be the same as given in this degree, 90 degrees. So, and triangle has 3 sides, order of rotation is 3, and if we divide 360 by 3, we will have 120 degrees, which is the same as rotation, the degree of the rotation, you see. So for the regular polygons, it's very easy to find the order of the rotation and the degree of the rotation, which we asked in our last homework. Good luck, guys. Hope that it is helpful for you. So any questions you can ask on Google Classroom. And so bye. Have a nice weekend. And good luck for the homework. See you next.